All right, good evening and welcome everyone to Mount Washington Observatory Science in the Mountains lecture series. My name is Brian Fitzgerald and I'm the Director of Education here at Mount Washington Observatory. Thanks so much for joining. And this evening, we're excited to welcome University of Utah professor Dr. Jim Steenburgh, who's going to be telling us all about the secrets behind the greatest snow on Earth. Well, thanks so much for joining us for tonight's program. For those of you who are not already familiar with Mount Washington Observatory, we are a nonprofit member-supported organization with a mission to advance the understanding of the forces that create Earth's weather and climate. And we accomplish that through operating our summit weather station with around-the-clock weather observation and forecasting, by conducting research and product testing projects, and by developing and offering innovative educational programs. If you have questions for tonight's speaker and you're joining us through Zoom, please make sure you use the Q&A button. You can find that right at the bottom of your Zoom screen there. Feel free, you can add a question whenever you'd like, so make sure you get your questions in. If you're joining us on Facebook, welcome. Thanks so much for joining us that way. We won't be able to respond to your comments or questions in real time, but following our program here, we'll try and respond as quickly as we can. If you'd like to join us for a program through Zoom next time, make sure you go and register over at mountwashington.org/SITM. Alrighty, well, I'm going to go ahead and launch a quick little poll for those of you joining us tonight. Got 4 questions for everyone joining on Zoom right now, so you should be seeing a poll pop up at the moment here. The first question being, where are you joining from? Love to know where you're joining from this evening for tonight's program. Perhaps it's a state within New England, perhaps somewhere in the tri-state region, Connecticut, New York, New Jersey, maybe somewhere else in the US, or perhaps outside the country as well. And then we have 3 trivia questions from our speaker this evening, some good ones. How much snow did Alta ski area get last season? You have 4 choices there, choose wisely. The third question, what ski area holds the world record for the most snow in a single ski season? Could be Wildcat ski area here in New Hampshire, Alta in Utah, Mount Baker in Washington, or Zermatt in Switzerland. And then last but not least, what road has the highest unmitigated avalanche hazard rating in the world? Is it the Mount Washington Auto Road? Is it I-70, Interstate 70 in Colorado? Maybe it's the Seward Highway in Alaska, or State Route 210 in Utah. All right, I'll give you at least 10 more seconds here to get your responses in for those of you who'd like to participate. I see quite a few have already participated now. We'll close the poll in 4, 3, 2, 1. All righty, and let's see what we came up with here. So sharing the results at the moment, good representation from both New Hampshire and Massachusetts, as well as the rest of New England. Quite a few of you joining from the tri-state region. And then from outside the region as well, got some decent representation, 8% of you showing up from elsewhere in the US, and then even a couple folks from outside the country as well. Welcome to everybody. All right, so how'd you do on the trivia? How much snow did Alta ski area get last ski season? Well, almost half of you said 843 inches. What ski area holds the world record for the most snow in a single season? Most of you said Alta in Utah. After that was Mount Baker in Washington. Last place, Wildcat. I guess people aren't feeling strongly that New Hampshire has that record. And then what road has the highest unmitigated avalanche hazard rating? Most of you, more than 57% of you exactly said State Route 210 in Utah. Ooh, surprised we didn't see more Mount Washington Auto Road responses. All right, well, I'll stop sharing there. And at this time, I'd love to welcome our speaker, professor at the University of Utah, Dr. Jim Steenburgh. Jim, can you hear me?
Yes, I can.
Hey, I can see you and I can hear you. Bonus.
Yeah, great to see you. Answers to those questions are 903 inches at Alta last year. Snowiest ski area in the world record set by Mount Baker ski area. And the highest unmitigated avalanche hazard rating in the world is for State Route 210 in Little Cottonwood Canyon in Utah. And we'll learn all 3 of those things in this talk today.
900 plus inches of snow, huh?
Yeah, I only skied about 850 of them, so I missed a couple days in there, but for the most part, it was a pretty good ski season here.
Well, wow, that's hard for me to wrap my head around. But anyways, Jim, I'd love for you to take it away. We're excited to hear what you have to share this evening. Thanks so much.
Sure thing. Let me share my screen and see if I can get my into presenter mode. Great. Brian, how does that look?
Looks great. Thanks.
Good. Well, this is a talk, Secrets of the Greatest Snow on Earth, that's based on a book that I wrote originally about 10 years ago, but the second edition just came out. And the idea for this book really came from me riding chairlifts with people or being skiing in the backcountry with people. They find out I'm a meteorologist and they start asking me questions. And when you live in Utah, one of the first questions they ask you is Utah snow really the greatest on Earth? And they also want to know when the next snowstorm is going to come. They want to know how climate change is going to affect skiing. So the book and this talk here try to delve into some of those issues. What we're going to start with here are what I call kind of the secrets of the greatest snow on Earth. And the first secret is, where did this term greatest snow on Earth come from? And there's a little bit of an interesting story there, because maybe about 10 or 15 years ago, the state of Utah was sued for trademark infringement by the Ringling Brothers and Barnum and Bailey Circus, because their motto or their slogan was the greatest show on Earth. And Utah's very popular trademark slogan was the greatest snow on Earth. And what was interesting is, as part of that lawsuit, there were a group of people that tried to find the origins of this term greatest snow on Earth, and nobody could find it. But I really wanted to find it for my talk for my book. And so I had this ace in the hole. And the ace in the hole was somebody by the name of Dave Hanscom. I think Dave is originally a Mainer, or he's from New England. He went to Middlebury College and he moved to Park City a few decades ago. And he's a legend here in Utah with the Nordic skiing community. And so I asked him if he knew where it came from. And he said he didn't know where that phrase came from, but he thought a guy named Mike Karolagos knew where it came from. So I happened to be at our Natural History Museum here in Utah one day for a big function, and who was standing next to me but a guy with a name tag on that said Mike Karolagos. So I struck up a conversation with him. He was a PR person by training, but he used to write for the Salt Lake Tribune, the major newspaper here in Utah. And he told me that his brother came up with it. I thought that was probably a pretty crazy story, right? Your brother came up with it. But I looked up his brother. Turns out his brother was a US ambassador to Belgium. And he had helped over 300 people through Senate confirmations for judges and that sort of thing. So he seemed like a pretty reputable guy. So I struck up a conversation with him, and he told me, yeah, I came up with that in the early 1960s. The Ringling Brothers and Barnum and Bailey Circus was in town, and I thought, greatest show on Earth, greatest snow on Earth. That's just a perfect play on words. So I spent a long time in our library here at the University of Utah, and eventually I found the article that Tom wrote, which was published on December 4th, 1960. And this is the first use of the phrase greatest snow on Earth. And in the article, Tom writes that the Intermountain West folk will tell you that the winds blowing from the west leave the wet, sticky snows in the Sierras. When the storms reach the Intermountain ranges, only the most perfect dry powder is left. And he goes on to describe the region and conclude with, that's the extent of the Intermountain's big top, which supports this real, true greatest snow on Earth. And that was when the Utah legend was born. But there's some problems with this phrase, greatest snow on Earth. And first of all, it's kind of the conventional wisdom. And I pulled a couple of these phrases from ski publications, like what would have been Powder Magazine back in the day. And the statements like, the greatest snow on Earth is more than a catchy slogan. It is a scientific fact that Utah's snow is lighter and drier. Or because of the high salt content of the lake, storm clouds create a unique type of snow that is particularly light and dry. Experts call it the lightest, driest snow anywhere. Well, scientists like me have a phrase for phrases like this, and it's called BS. There's no evidence to support these things. In fact, one of the dirty little secrets of Utah snow is we don't really get exceptionally dry snow. In fact, the snow in Utah, if we look at the average water content of snow across the continental United States, the snow in Utah is not exceptionally dry. You can find drier snow, for example, in Montana, Wyoming, and much of Colorado. And even the upper Great Lakes, the lake effect snow belts in that area get drier snow on average than Utah. So it's a myth that Utah snow is unusually dry. On the other hand, the powder skiing reality is that the best deep powder skiing is not necessarily found in the driest snow. And this is a quote that I like to use from Ed LaChapelle. Ed LaChapelle is really the grandfather of avalanche research in the United States. He probably knew more about snow than anybody that's ever walked the face of the earth. And he has a paper from 1962, and I like this quote where he says, "The best deep powder skiing is not found in the lightest snow, but rather in snow with enough body to provide good flotation for the running ski." And we'll talk about what that body is here in just a second. So the real secrets of the greatest snow on earth are, and why Utah has become such a magnet for deep powder skiing, is number one, we get a lot of snow. We have abundant snowfall. In Upper Little Cottonwood Canyon, the average snowfall at Alta ski area is over 500 inches a year. That's an exceptional amount of snow. But there's a few other reasons. One of them is that our climatology is geared towards lots of what I call Goldilocks storms. These are storms that aren't too big, they're not too small, but they're just right. For real deep powder skiing, you need about 10 inches of new snow. If you have less than that, the skis tend to ride on the underlying surface and you don't get true bottomless skiing conditions. But when you get over 10 inches, then you start to get real ski flotation. On the other hand, you don't want these behemoth storms either. You don't want 30, 40 inches of snow because then the avalanche conditions are too bad and you can only ski on the steepest slopes. And on those slopes, it's just too dangerous when you have that much snow. So this Goldilocks range is somewhere in the 10 to 22 or 24 inch range. And our climatology is geared for lots of those storms. The other thing about our climatology that's really favorable for great powder skiing is we get lots of what are called right side up snowfalls. These are storms that start off with higher density snow and the snow gets drier over time, lower density over time. And that means that the lightest snow, the lowest density snow sits on top of higher density snow, and that's optimal for ski flotation. On the other hand, if you get what we call an upside down storm where high density snow sits on top of low density snow, then the skis tend to dive, they tend to submerge, and the skiing is a lot more difficult. So these three things are the real reasons why Utah snow is known as the greatest snow on earth. That's our claim. We'll see in a little bit, though, that there's at least one other region that might be able to give us a run for our money. So let's talk a little bit about some of the things that happen here in the Wasatch and happen in other mountainous regions around the Western United States and around the world. So I'll talk a little bit here about Wasatch microclimates. So one of the dirty little secrets of Utah skiing as well is that everybody doesn't get 500 inches of snow a year like Alta ski area does. In fact, it's the Cottonwood Canyons that are southeast of Salt Lake City that are kind of the real powder skiing mecca for Utah. And this has been known for almost 100 years. In fact, it's really quite interesting. There was a weather service. It was a National Weather Bureau back then. The U.S. Weather Bureau became the National Weather Service. There was a meteorologist there named S.D. Green. And in the 1930s, he was a backcountry skier. He used to take a train to Park City. He would climb up over the Wasatch Crest and into the Cottonwood Canyons into what's called Big Cottonwood Canyon. And he has a great quote from 1935 where he said, "Skiers will eventually find that the heads of the Cottonwood Canyons offer the best skiing to be had in the Wasatch Mountains." And he was really right about that. When you look at the topography and the geography of northern Utah, this is what you see here. We have the Great Salt Lake, shrinking, unfortunately, and still small, but still out there. And then in this area here, this is we sometimes refer to as the Central Wasatch Mountains. These are maybe about, this box that you see here is about 30 kilometers or 18 miles on a side. We have two canyons, Little Cottonwood Canyon, Big Cottonwood Canyon, that contain ski areas that come up from the Salt Lake Valley. And then on the Wasatch back, on the east side of the Wasatch Range, there's Park City Mountain Resort and Deer Valley. But when you look at the average snowfall in this region, what you find is the area around Little Cottonwood Canyon, noted here with LCC. This is by far the snowiest part of the Central Wasatch. It's a very localized microclimate. It's the highest terrain in the Central Wasatch. And the snowfall here is about 40% greater than it is at the same elevations on the Park City side of the range, this area that you see right in here. So this area in the Cottonwoods, Little Cottonwood Canyon, Big Cottonwood Canyon, this is really powder skiing mecca for Utah. And it's really, that is where Utah's reputation is strongly based on. And it's where everybody wants to go skiing on a powder day here, which is why the traffic can be so bad on a big dump, after a big dump. Now, what's so special about these canyons? This is something that happens in mountainous regions all over the world, something that we call orographic precipitation. So, or we call orographic lift and precipitation enhancement. Basically, we have a situation where we have flow, say moist flow that's impinging on a mountain range. The air gets forced upwards. Sometimes there's low-level blocking that prevents the flow from coming right to the base of the mountain, but it starts to go up before you get to the base of the mountain. Or an unblocked situation, it goes right to the base of the mountain, gets forced up and over. And this is a way to cool the air mass and create clouds and enhance precipitation. I see somebody has their hand up. I'll get to that in just a second. So this happens, for example, on Mount Washington. It happens in the White Mountains of New Hampshire. But one of the things that's really nice about the Central Wasatch, and in particular the high terrain around Little Cottonwood Canyon, is it's a mountain range that's exposed to flow from multiple directions. So in this picture that you see here, this is a three-dimensional view looking towards the southeast. If the flow is out of the northwest, it gets forced up and over that terrain. If it's out of the southwest, it gets forced up and over that terrain. If it's out of the southeast, it gets forced up and over that terrain. So this area in Little Cottonwood, it's got the highest terrain. It sees the greatest precipitation enhancement, and that's one of the reasons why it's become powder skiing mecca. Let me take a look. Brian, can you? There's a question there. Can you possibly unmute?
Sure. Yeah. Hey, hi, Paul. You had your hand raised. Do you have a question you wanted to ask? Or Paul, feel free, if you're able, you can use the Q&A button to ask a question there, and I can certainly interrupt Jim at a point, but we'll also make sure to save some time for questions at the end. So
looks like he put his hand down, so hopefully he can ask later, perhaps, and we'll get to it there. Now, this area around Park City is much drier because it's on the downstream side of the Wasatch, but there are times where it can actually get more snow, say, than in Little Cottonwood Canyon. And those are situations where the flow actually reverses temporarily. So in storms that produce southeasterly or easterly flow, this is a view now looking at the Central Wasatch towards the southwest. In that situation, the backside of the Wasatch, the eastern side, which is typically the lee side, temporarily becomes the windward side. And those are some of the best powder days that you're going to find at Deer Valley and at Park City. So that's a little overview of the greatest snow on earth and Utah skiing. I'd like to kind of shift gears now and talk about some of my favorite microclimates around the world and some of what I think are some of the cooler snow microclimates around the world. So one of the trivia questions pertain to what ski area observed the most snow, has the world record for snowfall in a season. That was Mount Baker ski area. Mount Baker shared this photo with me from my book of the snowbank that existed there during their world record year. So in the 1998-99 season, so these are observations collected from July 1st to June 30th, Mount Baker set the world record for recorded snow in a year of 1,140 inches, and that just barely beat Paradise Ranger Station on Mount Rainier, also in Washington State, which set the previous record, which was, I believe, 1,100, maybe 22 inches, a little bit lower than that on Mount Rainier. So I actually had the good fortune of living in Seattle for 6 years when I was going to graduate school. I love skiing in the Cascades. It's a beautiful mountain range. One of the things I loved about it was the enormous snowpack. The snowpacks there are just phenomenally huge. And sometimes you wonder if they're all going to melt in this. It's going to melt in the summer. This year it has, but some years it doesn't. And little known fact, I grew up in upstate New York. I grew up northwest of Albany, right in the southern tip of the Adirondacks, about right in here. So my father was a cross-country skier and a hiker, and so we did a lot of cross-country skiing when I was a kid, especially in the western Adirondacks in the Old Forge area. So I got really interested in lake effect snow when I was a kid. And one of the cool things about it was about 30 years later, I got to do research on what happens on the Tug Hill Plateau. And the Tug Hill Plateau sees probably the most intense snowstorms in the world on a regular basis. Snowfall rates over 5 inches an hour very frequently. We worked there for a month in December of 2013, and we observed 4 storms with peak snowfall rates of over 5 inches an hour. Pretty incredible stuff. And those storms are produced by these very intense, what meteorologists call long lake axis parallel bands. These are narrow bands that form along the major axis of elongated lakes like Lake Ontario and Lake Erie. So Buffalo, for example, is an area that gets these really intense snow bands. Buffalo's been severely impacted by these many times over the years. But the Tug Hill Plateau, fewer people, but also very, very heavy precip rates. snowfall rates. So that's one of my favorite places to study snow. The Alps, of course, are the birthplace of alpine skiing. That's why it's called alpine skiing. And interesting thing about the Alps is that the most snow and the most precipitation doesn't fall in the highest elevations. The Alps are kind of such a big mountain range, and they're so broad that when you look at a place like, say, Western Austria and Northeastern Italy, this is a map of the average annual precipitation. Even though the terrain is highest in this area that's near the Italian-Austrian border, it actually, there's more precipitation on the southern and the northern rim of the Alps. Even if you go into places like Zermatt, where you have numerous peaks that are over 4,000 meters, extremely high, it's still greater precipitation in the lower to mid elevations on the southern rim of the Alps and on the northern rim of the Alps. So if you're looking for powder skiing, kind of a funny thing about the Alps is these higher interior mountain ranges have more reliable snow conditions, but they don't get as much snow. If you're looking for powder, you want to find higher elevation areas that are along the northern rim or along the southern rim. So one of these areas, for example, is the Arlberg area of Western Austria, the Arlberg Pass, which encompasses St. Anton, places like Lech and Zurs. And this is one of the snowiest ski resorts during the winter season that you can have there, because it's relatively high elevation and it's on the northern rim of the Alps. But my favorite snow climate is in Japan. Japan is an incredible place. It gets incredible amounts of snow. And if you're a real snow lover, you have to go there once, preferably in late January or early February. And here's why. Japan sits downstream or west of the largest continent in the world, which is the Eurasian continent. It gets the strongest high pressure systems and the coldest air masses. And these pour off of the mainland Asian continent and over the Sea of Japan during what's called the winter monsoon. So this is a period where there are many, many, many cold air outbreaks over the Sea of Japan. The Sea of Japan is, trying to remember, I think it's 12 times bigger than Lake Superior, and it has a warm current in it that comes up the west side of Japan to keep it nice and warm. So you're just getting cold air outbreak after cold air outbreak after cold air outbreak over this warm body of water. And this creates sea effect storms, which are very just like lake effect storms, except unlike the Great Lakes of the eastern United States, where the topography is really small, there's a lot of big terrain on Honshu and Hokkaido Islands that these lake effect storms run into. So you get copious amounts of snowfall. In fact, the snowiest inhabited place anywhere in the world is Tsukayu Onsen on the northern end of Honshu, with an average annual snowfall of 694 inches. Just incredible amounts of snow. This area is called the Gosetsu Shitai. It's the heavy snow area. And if you look at the statistics, for example, from Hokkaido Island, from a place like Kuchin, this is a Japanese Meteorological Agency observing site, the winter monsoon is very, very intense, focused on the month of January. So if you look at the mean monthly snowfall in Kuchin, it goes up from 40 inches in November to over 140 inches in January. This is based on the 1981 to 2010 norms. I think they've gone down a little bit for the most recent ones, but still enormous amounts of snow in January, and then it drops off very rapidly in April. If you compare that to Alta, Utah, for example, you can see the monthly snowfall doesn't have that much of a peak. So in Japan, they get this incredible peak in snowfall in the month of January. And at only 590 feet elevation, it's 480 inches of annual snowfall in Kuchin. And 90% of the Januaries see more than 100 inches. So probably the surest bet for deep powder skiing anywhere in the world is in late January on Hokkaido Island, especially near the Sea of Japan. As you go inland, the snow drops off very quickly. So that's something to keep in mind if you ever plan a ski vacation there. All right, shifting gears again now, let's talk a little bit about avalanches and some of the things that happen in Little Cottonwood Canyon here in Utah, because it's a pretty cool place. If you're into really exciting and hazardous mountain weather. Alta, I always tell people that Little Cottonwood Canyon, where Alta is a very dangerous place if Mother Nature is left to her own devices. And the first people to discover this were miners. So the history of the parts of the Western United States, and in particular Little Cottonwood Canyon, is mining in the late 1800s. So in 1864, silver was discovered in Alta, and silver mining was the primary economic driver there until about 1920, when a depressed economy resulted in a cessation of most of the mining activities. Numerous avalanches in this area killed miners. This is a historical photo of what is the town of Alta today. You can see how it had been wiped out by avalanches. In 1884, the Salt Lake Tribune estimated that 143 people had been killed there in snowslides. Today, the Alta Historical Society estimates the number was closer to 74. But it was quite dangerous. And it's quite dangerous because it snowed a lot. There's lots of steep terrain, but the miners made it even more dangerous by denuding the terrain of all the trees, which can act as anchors in avalanches. And just to highlight that, you can see this picture here. There's no trees there. And this is what it looks like today. So today, thanks to revegetation efforts, we have lots of trees there, which is good. But basically, you had lots of miners basically trying to keep warm, cutting down trees to process ore to stay warm. And that made it even more dangerous. For anybody who's been to Alta, these are what these runs are today: High Rustler, Eagle's Nest, Mount Baldy. And there you go. This is the famed High Rustler run at Alta right here, what it looked like in 1885. Eventually, though, people realized that powder was the real treasure to have up there. And there were two issues now. One was getting people up the canyon safely to go skiing, and the other was backcountry skiers. And backcountry skiers, people have been going into the backcountry here in Utah for a long time. I like to remind the youth of today that people were backcountry skiing as soon as they started skiing in the Cottonwood Canyons. This is a quote from the U.S. Forest Service supervisor in the mid-1940s, saying that winter skiers wander all over the landscape. Many are not content to stay on the practice slopes and on the ski runs close to the lift. An increasing number are seeking ways of getting far out into the alpine hinterlands, far away from the snow bunny crowd. So now you had risk along the highway, but also in the backcountry adjoining the ski area. So Little Cottonwood Canyon today, on a typical day in the wintertime, you have 7,000 cars traveling across 50 avalanche paths over a distance of about 10 kilometers or 6 miles. The highway is hit by an average of 33 avalanches a year, usually when the road is closed, but not always. We have about every year or two a car or a vehicle that gets swept off the road by an avalanche while the road is open. There's an index that's been designed to assess avalanche hazard along highways, and State Route 210 through Little Cottonwood Canyon has the highest unmitigated avalanche hazard index of any major road in the world. Alta and Snowbird are the only places in the United States where live artillery is shot over the heads of civilians. When this happens, they declare what's called interlodge, which means you have to stay indoors, you can't go outside. That's going to eventually be phased out, say, over the next 8 to 10 years. And the estimated cost of closure for revenue to the ski areas is around $3 million a day. So it's very important to keep the road open. So here's an avalanche map of Little Cottonwood Canyon. You see the scale here, distance of about 2 miles. So this covers a stretch of maybe a little bit over 6 miles. There are 50 avalanche paths that you pass through during that particular drive from the lower canyon, mid canyon, and upper canyon. This is a nice photo that shows the highway. So State Route 210, SR 210 here, going up Little Cottonwood Canyon. This is where Snowbird ski area is. This is where Alta ski area is. And these mid-canyon avalanche paths are amongst the most problematic, in part because they're the hardest to do avalanche mitigation work in. They're hard to shoot into. They're in wilderness areas. Oftentimes they have to use helicopters to bomb them. Tanners, for example, gets bombed by helicopter usually. And some of these slide paths are really big, like the Tanner slide path here that runs down to the road. And this is the Maybird slide paths, and we're going to see some of the damage from that here in just a minute from this past winter. But this is one of the more problematic stretches of highway. So the avalanche mitigation systems that are used in Little Cottonwood Canyon. Little Cottonwood Canyon is one of the few places left in the Western United States that is still using large artillery. These are 105 millimeter howitzers, military grade weaponry that fire large shells across the canyon and into the avalanche paths on the other side of the road. These are being phased out and being replaced by what are sometimes called RACs, which are remote avalanche control systems. And these remote avalanche control systems include GasX exploders. And these are kind of pipes that come up out of the ground, and they have a propane tank there and an oxygen tank, I believe, and they set off an explosion that gets directed onto the snowpack to trigger avalanches when the road is closed and to reduce the avalanche hazard. More frequently, or more commonly now, we're using these Wiesen towers. These were developed by a company in Switzerland. They have a big canister that gets flown in by helicopter, and using literally from an iPhone, you can, somebody who has permission to do this, can remotely lower a charge over the snowpack, have it go off and trigger avalanches before they get to be very large. And these get flown in several times during the course of the winter as they use up the charges. And we still are using some avalaunchers. These are smaller guns that shoot smaller projectiles into some of the avalanche paths. So let's just see an example of this. This is actually from a couple of years ago, a mid-canyon slide path known as Jedediah's. And hopefully you'll be able to hear the commentary from the Utah Department of Transportation Avalanche Control Team.
Oh yeah, that got it all.
Big and, well, that got all of it.
You can see the highway here. So this is a path that at this particular time ran to the highway. You can see it's closed. It hasn't been plowed.
Nice work on that one, Roller. 3.5, maybe 4. You see.
You heard some numbers called out. 3.45 avalanches are rated on a scale from 1 to 5, and 5 being the largest. So this was a fairly large avalanche path, or avalanche, I should say. All right, let me get out of the video. Oop. So this past year was an incredible year for avalanches and snowfall in Utah. So as we mentioned during the survey, 903 inches of snow fell at Alta. And I didn't even think that was possible until this winter. It's an incredible amount of snow. And as a result, we had long-running avalanches that we haven't seen here in 40 years. So we had some paths running to the highway, hit the highway for the first time since the epic 1983 winter. Little Cottonwood Canyon was closed overnight 42 times. So Utah Department of Transportation closes the highway in the evening after they get everybody down. Then they shoot the road in the morning and they try to get it open. But the canyon was closed a few times for multi-day periods. Most of April, the canyon was closed. People were trapped in the upper canyon. There were food shortages. It was a real mess. And you can see some of the damage here. You can see the highway. This is the Maybird slide path here, how it's covered the highway. And it takes a long time to get the road reopened when this happens. So now let's I'm going to try to show a video here. Hopefully this is going to work, of some of the damage that you could see when the snow began to melt out this spring. This is a video that was taken with a drone by Tony Karolagos. So let's see if this is going to work. You can see some of these larger trees. These are probably 40 years old. This is a campground. This is a bathroom that was wiped out. This is that Maybird slide path. And here you can see the highway. So tremendous amount of damage all through the middle and the upper canyon here. Just enormous amounts of timber that were wiped out. Trees just blown right over. Pretty incredible stuff. Even if you were here, you found it hard to believe. So I'd like to conclude a little bit to talking about climate change. I have a couple chapters in the book called Withering Winters and the Fate of Skiing, and kind of what is happening to snow and ice on the planet, but with a focus on skiing. So the graph you see here are global temperatures, departures from the 20th century average temperature since 1850. And as you know, perhaps no surprise, we've been running over the last several years nearly 1 degree Celsius or 1.8 degrees Fahrenheit above the 20th century average temperature. And it's looking more and more likely that 2023 is going to be the highest, the warmest year in the instrumented record since the middle 1800s. An Intergovernmental Panel on Climate Change, IPCC, states that it's unequivocal that human influence has warmed the atmosphere, the ocean, and the land. There's widespread and rapid changes in the atmosphere, ocean, the cryosphere, which is snow and ice, and the biosphere. Those have all occurred. So one of the biggest changes has been, and what is ongoing now, is the loss of glacial ice, especially pretty much all over the world. And I had the good fortune of spending 2019, part of that year, on sabbatical in Austria at the University of Innsbruck, where a lot of glacier research is going on. And of course, glaciers are very important for the identity of Austrians. And there's been tremendous glacier loss, beginning initially with the emergence from the Little Ice Age and retreat. But over the last 30 years, human influence on climate has been the primary driver of glacier retreat and loss. And this is just one example from the Ötztal Alps in Austria. The loop that you see here is just a 10-year period showing the dramatic retreat and decline of both glacial area and glacial volume for one glacier in the Ötztal Alps. Interesting aspect, in the 1980s, summer skiing became very popular in the Alps. And I have a quote from my book here. Summer skiing became popular in the European Alps in the 1970s, and by 1985, there were 32 operating glacier skiing resorts. But dramatic glacier retreats and mass loss have occurred in recent decades. By 2021, only a handful of summer skiing resorts remained. And even these are really struggling. So Whistler, British Columbia, they used to have skiing on the Horseman Glacier in the August. And that's become increasingly difficult in recent years, as you can see from this tweet from Mike Douglas. Zermatt used to stay open 365 days a year, but last year they shut down because it was too hot and they couldn't stay open. Hintertuxer Glacier in Austria is still staying open 365 days a year, but you can see the tremendous effort, the snow farming, the use of insulating and sun-reflecting blankets and materials that they're using to try to protect the snow that they have to be able to keep their ski area running through the year. Now, most of their customers, when we're talking about summertime, a lot of these folks are ski teams, but it shows some of the impacts in the high alpine areas of climate change. When we look in the Western United States, we have pretty good records for a 1 April snowpack. And we can see for the most part, since 1955, there's been declining trends in snowpack. But those trends are not the same everywhere. If we look at the trends as a function of elevation, they're largest in the lower elevation areas. These are typically areas that are also near the Pacific Ocean, relatively mild. So it's these warmer, lower elevation areas that are seeing the largest declines. And the upper elevation areas, especially in places like Colorado, where you have observing sites that are over 10,000 feet, those are the smallest declines. So as I like to say, global warming is not an equal opportunity offender, at least in the recent decades. The declines for snowpack are largest in the lower elevations and in the warmer areas. We see this in other parts of the world. This is an example from Austria, looking at their snowpack trends since 1961. The squares that are in red, these are areas where there have been negative trends, and in gray is where there's been no trend. On the left, it's the seasonal mean snow depth, and you can see there's no observing sites in Austria that have positive trends, and there's quite a few that have negative trends. If we look at seasonal snow cover duration, so the length of the season that has snow cover at least a centimeter of snow on the ground or more, we see the same thing. In this case, we're looking at it as a function of station elevation. So you can see the declines are largest in the lowest elevations and smallest in the upper elevations. This is why the most vulnerable ski areas in the Alps to climate change are these low elevation ski areas. They're the ones that are relying the most on artificial snow and that are struggling the most. If we come here to the Wasatch Mountains and we think about what the future is going to hold, I'd like to show the difference, how there's elevation dependence of how our snowfall is going to be affected. So these are maps of the central Wasatch, and I've highlighted the regions that Snowbird, Alta, Brighton, Snowbird, Solitude, Park City, and Deer Valley ski areas are in. And what I'm going to do is I'm going to overlay an estimate of the percentage of wintertime precipitation that previously fell as snow that would instead fall as rain if there was 2 degrees Celsius of warming or 4 degrees Celsius of warming, over the 1979 to 2008 baseline. So these are contrasts from what we got in 79 to 2008, if there was 2 degrees C of warming or 4 degrees C of warming. So these areas in the warm colors are areas where we have a lot of snow that was previously falling, or precipitation is previously falling as snow that's instead falling as rain. In the reds, you're talking about 40 to 50% snow losses, which includes, for example, the base of Park City, the base of Deer Valley, areas that already don't get a lot of natural snowfall. On the other hand, the areas that see the least loss of snowfall are the upper elevations, for example, around Little Cottonwood Canyon, areas above about 9,000 feet. And in those areas, you're seeing snow losses that are a lot smaller. So these are areas that have insurance, some insurance against global warming. They're still going to feel the effects of global warming, but it's not going to be as dramatic as the losses in the lower elevations. So I've always said that Little Cottonwood Canyon and Big Cottonwood Canyon, these are going to be the last areas that are going to have really good, really viable skiing moving forward. It'll be a few decades before I think things get really bad there. So just some other examples from the Western United States of the importance of elevation. If we look at the change in days with number of days where the mean temperature during the ski season is greater than 32 degrees Fahrenheit, you can see that the increase is largest in these warmer and lower elevation areas. It tends to be smallest in Utah, for example, in the higher elevation Little Cottonwood area, or in Colorado, where there are these higher elevation ski resorts. If we look at rain on snow days, those tend to be highest in these lower elevation regions that are warmer, and they tend to be lowest in these upper elevation areas of Colorado. So you can see these trends in other areas. This is based on regional climate modeling by a group at the University of Wyoming. So global warming is not an equal opportunity offender. Warmer, lower elevation resorts will suffer the most. So with that, I'd like to conclude and thank everybody for being on and for paying attention. If you're interested in picking up the book, just a quick little plug here. It is available on Amazon and Barnes & Noble. I recommend you get the second edition, and I'll be happy to go in and answer some questions. So let me see what's popped up in the Q&A here. So first we have a question from Sam. How did the Barnum and Bailey lawsuit turn out? That turned out very favorably for the state of Utah. I don't know if I've got the legal language quite right, but the Utah slogan and trademark was not viewed as being negative for the Ringling Brothers and Barnum and Bailey circus. So Utah won that lawsuit. From Patrick, global warming is clearly a big problem. However, we have had record snowfalls last winter. Why are we having record snowfalls when global warming is such a problem? Maybe you're covering this in the presentation. Well, I didn't cover that. And that is an interesting issue. And I'm not sure I can give you a great question for it. First comment I'm going to make is that of all the snow measures, for example, fraction of precipitation that falls as snow, amount of snowfall, end of season snowpack, end of season precipitation that's, say, held in the snowpack at the end of the snow accumulation season. Snowfall is actually the one that will emerge, or the trends will be hardest to see. We'll see those last compared to all these other snow measures. And there's a few reasons for this. One is, even though the fraction of precipitation that falls as snow is declining in a number of areas, not in the highest elevation areas, but in some areas, precipitation in some areas is increasing. So if you go, for example, to the Cascade Mountains of Washington, they're getting more precipitation. If a greater fraction of precipitation falls as rain instead of snow, it's being partially offset by the increase in precipitation. But why last year was such a big year? Mother Nature just happened to lock in for the Sierras and the Wasatch. And it's still cold enough that when we get the right jet stream pattern, we get a ton of snow. Weather variability is still built into the system. So that's how I would answer it. Alta, for example, has a base elevation of 8,500 feet, and they collect their snow observations at 9,600 feet. And that's still very high relative to where the freezing level is in most storms. We're in the process of working on a paper. We looked at the last 23 years, and almost 100% of the precipitation that fell there from November to April fell as snow in the current climate. So even with a couple degrees of warming, it's still mostly snow there.
Well, hey,
Okay, another
Jim,
question here. I'd like
sorry,
to find
Jim, I was-
some land in the Wasatch area to lease for 5 to 6 weeks in the summer. Would like to tell, I can't help you with that. Airbnb.
Hey, Jim, sorry, I want to jump in just for a second because,
Yeah.
well, first of all, thank you very much for your presentation. I glued the entire time. I wanted to remind folks that they can use the Q&A button if they're on Zoom. They can use that button. It's right at the bottom of the toolbar there to get your questions in. Thanks to those people who put questions in already. Yes, thank you for providing your contact information there, Jim, because it looks like Sam will reach out and connect with you and for other folks who have questions. I just want to jump in and answer a question for Patrick, who's asking about accessing and recording this presentation. You can find that at our website, mountwashington.org/SITM, or if you follow the observatory on YouTube, it'll be on our YouTube channel as well. So thanks for that question. But go ahead, Jim, whatever else you find in the questions here, please feel free to jump in.
Yeah, I don't know what happened. I can't actually scroll through the Q&A now. Let me just see if I can get, okay, there we go. Let me see if I can get a couple of these. Is there a story to go with the lost? I don't know what the story is. I just know they lost. I'm not a lawyer to understand the legalese on that. All right, what specific research am I doing at the University of Utah? So I work mostly on winter storms and snowfall prediction in mountainous regions. We have worked, though, quite a bit on lake effect storms. So over the last 10 years, we've done quite a bit of work on Lake Ontario, for example, how it helps to initiate and organize lake effect snow bands, what happens to those snow bands as they interact with the Tug Hill Plateau. So we've tried to understand under what circumstances do we see a lot of enhancement over the Tug Hill Plateau versus, say, not much enhancement, and all the way into the Western Adirondacks. So we have a paper just came out looking at snowfall in the Western Adirondacks, lake effect snowfall. Under what situations is there a lot of penetration of these storms into the Western Adirondacks? We've also done a lot of work in Japan. That really helped to inform kind of what I've done on that. We've collaborated with Sento Nakai and other people at the Nagaoka Snow and Ice Center to understand sea effect storms there and kind of how they interact with topography. And that was a lot of fun. I'm a big skier, so I really like to study winter storms. We do a lot of work trying to improve snowfall prediction over the Western United States. So right now we're developing machine learning techniques to try to better forecast snow to liquid ratio or the density of snow, for example, which is really important for avalanche forecasting. But it's also important for getting snowfall amount forecasts right, because that's part of it. When we get in Utah, for example, at Alto, we sometimes get storms that give us 30 inches of snow for every inch of water. These are incredibly dry snowfalls. It's really hard to get the snowfall amount right. So we're working on that as well. At the University of Utah, there's a lot going on in snow hydrology. Trying to understand what's going to happen to snowpack over the Western United States over the next few decades is a really critical problem. We are mired in a deep multi-decadal drought still right now. Last year, notwithstanding, water resources are still in a very precarious position. In Utah, the Great Salt Lake has been shrinking. We've recovered a little bit this year, but not a lot. We have a long ways to go to get up to what's considered to be a kind of a safe, stable lake level. So trying to predict those things, trying to understand not just the effects of greenhouse gases on the climate system, but also dust. For example, we have dust storms here. The dust gets deposited in the snowpack. And during the spring, the water trickles down through the snowpack and the dust emerges at the snow surface. And that results in more solar absorption, more absorption of sunlight, which causes the snow to melt faster. And that affects the timing of runoff and when it can be caught captured by the reservoirs. So all of that are some of the things that are going on here. Okay, question: with global warming, are more high elevation thunder snow events being observed? That's a hard question to answer because thunder snow events are pretty rare. So we don't get that many of them. So it's hard to detect trends. I don't know the answer to that. I'm not even going to speculate on it, except to say that I've had some fun, but also some scary experiences backcountry skiing in thunder snow. I remember once finishing a long ski run, and we were near an avalanche path when we heard this incredible rumble. And I remember the hair stood up on the back of my neck, and then I realized it was thunder and it wasn't an avalanche, thankfully. So I've had some of those. There's also a question here. What is the effect of snow creation on ski slopes? I'm not sure what you mean by snow creation. I'm going to guess snow making. So making artificial snow. So man-made snow, or I should say human-made snow, that of course is critical for the ski industry in New England. Even in Utah, it's hard to believe, but a place like Alta that averages 500 inches of snow a year makes an awful lot of snow. They make a lot of snow in November to try to open for Thanksgiving and to make sure they have a durable surface in place for Christmas and the holiday period. So Utah, I always joke that Utah is the greatest snow on earth, but we also have the greatest snowmaking on earth, because not because our snowmaking systems are all that complicated, but from a weather perspective, we have a lot of high altitude, cold, dry conditions, and these are really optimal for snowmaking. So the funny thing is Alta ski area can really pump out a lot of man-made snow on their primary runs. What is the effect on those ski slopes? That's complicated. I don't really know the answer to that. Like if you went to a place like Killington that makes an enormous amount of snow, I don't know what the impacts are on the rivers and the creeks of Vermont. It's not something I've ever really thought about. Here, I would say it does increase the snow duration season on those slopes, but it covers a very small fraction of the land surface here in Utah. So anyway, that's a hard question to answer. I think that's, there's one more here. Let's see, are certain weather patterns or systems that predict whether a winter will be snowier or not? Yeah, and the answer to that is yes, but it depends on where you live. The primary kind of driver of kind of jet stream characteristics in North America is whether or not we're in an El Nino or a La Nina. And this winter is going to be an El Nino year. And El Nino or La Nina load the dice for a given winter. It doesn't guarantee what's going to happen, but in some parts of the United States, it loads the dice maybe for a better snow year. So if you're in, say, the Northwest United States, presence of La Nina loads the dice a little bit for a better snow year. The presence of an El Nino loads the dice for maybe a poorer snow year, but it doesn't guarantee it. Other parts of the United States, for example, New England, I don't know enough about what happens there to say what's going to happen. You have to consult with your weather experts. But that's one of the things that we look at to try to produce seasonal forecasts. For northern Utah, we don't really correlate with anything here. We honestly have no idea what this winter is going to be like. So if you're thinking about making a reservation to come here on vacation, my usual comment is a bad year here is better than a good year elsewhere. So don't worry about it. But it doesn't mean you're going to have great snow while you're here. Last year, we had great snow almost the whole year, but there were a lot of days you couldn't even get to the ski resorts because the avalanche hazard was so high. So you just don't know what you're going to get.
Well, Jim, I think you've done it. You have answered questions that have come in. I think one more is just popped in, maybe from a skier's perspective, and use your meteorologist hat. What mountain do you recommend buying a ski pass to? Asked James.
Yeah, I try not to give endorsements. You know, an interesting thing in the ski business is they've moved to these mega passes, we could call them. So there's two major mega passes, the Icon and the Epic, and these give you access to many ski areas. In Utah, most of the ski resorts are Icon resorts, with the exception of Park City Mountain Resort and Powder Mountain, which is not on either one of these. So Icon tends to be very popular in Utah, but that's not an endorsement of Icon, nor is it let's say anything bad about Epic. It's really a personal choice. So anyway, yeah.
Well, thank you, Jim. I don't know if you'd entertain just one last question. I was curious. I know there's a question about certain weather patterns and how you might predict snowier or less snowy years, but I think you referenced it quite a bit, but could you just speak a little bit more to the Wasatch and the types of systems and weather snowstorms that are kind of created? Because I mean, for context, for a New England or Northeast based audience largely here this evening, we're used to the nor'easter, the coastal low pressure system, an Alberta clipper, those sorts of types of storms. What is the sort of typical storm
Yeah, you know,
is producing
everything that
gold
you've learned
stars.
and experienced on the East Coast does not work here. It doesn't work here at all. I grew up in upstate New York, and I always tell them, I've had a lot of students that have come from New Hampshire, a few that have actually, you know, been interns at the Mount Washington Observatory. And the first thing I tell them is, if you're a Seinfeld fan, you'll understand this. There's a episode of Seinfeld where George Costanza, one of the key actors, says every instinct he's ever had in his life has been wrong, and from now on he's going to do the opposite. And I tell them that's the way you need to think about the weather in Utah. You know, in New England, you know, your snowfall, your biggest snowstorms are produced by nor'easters, right? These are big coastal low pressure systems. You also get some from Alberta clippers, and then you can get, you know, the garbage bag or the horrible stuff with the storms that track to the west, right? You're in an area where you have warm air that's moving over cold air. So then you get freezing rain, sleet, those kinds of things. We don't see freezing rain or sleet is extremely rare in Utah. We may have had a few hundreds of it, say in Salt Lake City over the last decade. I can think of one event that put down just a couple hundred inches of it. We get storms from every direction here. We get them from the southwest. We get them in southwesterly flow, northwesterly flow. We get them from everywhere. And that's why Alta is so snowy. And the mountains create the weather, right? But Alta they're famous for this northwesterly flow storm. So these are cold snowfalls that happen after the cold front goes through. In New England, when the cold front goes through, unless you're in a very special place like Jay Peak, it tends to get cold and it tends to get clear. In Utah, it starts snowing. You know, a place like when you're on the windward side of the Wasatch Range, when you're in Salt Lake City, or you're on the western side of the Wasatch, that's when you get the most snowfall. So these northwesterly unstable flow with lots of Pacific moisture, sometimes enhanced by the Great Salt Lake. That's when we get a lot of snow at a place like Alta. But we get snow from other patterns too. It's really quite remarkable. The bad thing about the snow climate here, if you were to complain, is when we do get high pressure here, you know, we can get blocked for long periods of time. And part of the reason why we're in this kind of quote decadal mega drought is we've had a lot of high pressure over the last decade or two. And when that's the case, we don't get the storm track here because we're at 40 degrees latitude. So we're quite a ways south. And that's just kind of an unfortunate thing. But for the most part, the snow climate in northern Utah is more reliable than it is in other parts of the western United States.
Yes, we are all too familiar with that horrible mixed bag of precipitation around here. And boy, it'd be a lot simpler for everyone's lives, perhaps, if it was just all snow around here.
Yeah, I really hated, when I was a kid, that was just painful to see the snow. And I brought two people from the western United States with me to the Tug Hill Plateau. And we were there not just for lake effect storms, for other storms too. One night we went to bed and there was like 8 inches of snow on the ground, and we woke up the next morning. It was foggy. It was like 50 degrees and there was nothing but mud left, and they couldn't believe it. They'd never seen that happen before. I said, welcome to the Northeast United States.
Oh yeah. Thaw events. Gotta love them. Well, Jim, I really appreciate you presenting this evening, sharing your expertise. Fascinating stuff for sure. And thanks for sharing your contact information. Please feel free for our audience tonight, reach out. You're welcome to stop sharing your screen, Jim. And just for everyone who's joining, you know, if you enjoyed tonight's program, definitely would strongly encourage you to make a donation, help support programs like these over at mountwashington.org. You can hit the donate button in the upper right-hand corner. If you have thoughts about tonight's program, we'll have a survey that follows tonight's presentation, and also as an email reminder as well. Please, we welcome your feedback and ideas for future programs as well. And finally, don't forget to join us for our next Science in the Mountains program. It's on Friday this time, not a Tuesday, Friday, October 27th at 6:30 p.m. And we look forward to a special hybrid in-person and virtual Science in the Mountains program with the University of New Hampshire astronomer John Gianforti. He's going to be talking all about the upcoming 2024 total solar eclipse taking place this April. So don't forget to register for those programs or watch any ones you might have missed previously. And thanks again for joining. Thanks, Jim. I really appreciate it. Have a great night.
Thanks, Brian.
Yeah, take care, everybody. Bye-bye.